1 million years ago, something inside an African cave burned. Not from lightning, not from a wildfire sweeping across dry grass. This was deep inside a cavern, roughly a kilometer from the entrance, in a chamber no accidental spark could plausibly reach. Someone, or something, had carried fire into the dark on purpose. And here is the part that still unsettles the archaeologists who found it. Whoever did this almost certainly wasn't us. Not Homo sapiens, not anyone who looked like you or me. The strongest suspect is a species that vanished long before our own ever existed, and to this day, researchers can't fully agree on how much that creature actually understood about the flame it was keeping alive. We tend to think of fire as background scenery in the human story, something early people simply had the way they had hands or feet. But that's backwards. For most of Earth's history, fire was purely a force of nature, indifferent and lethal, and animals had evolved for millions of years to avoid it on instinct. What happened in that cave, and in a handful of other sites scattered across 3 continents, is among the earliest evidence we have of a hominin doing something extraordinary, refusing to run. And there's a deeper question buried inside that moment, one this story will keep circling back to. Finding evidence that a creature used fire is not the same as proving it could make fire from nothing. That distinction sounds small. It isn't. It may be the difference between an animal that got lucky once and the beginning of everything that came after. Picture the physical improbability of it first. A creature with no claws, no fangs, no fur immune to heat, deliberately reaching toward the one force capable of killing everything in its path faster than almost anything else in nature. Fire can race across dry grass faster than a human can outrun it. It consumes in minutes what took decades to grow. Most animals on the savanna evolved to treat it as something to escape, and still do. Somewhere in that arrangement, a hominin whose brain was substantially smaller than ours looked at flame and didn't flee. Try to imagine the first time it worked, the first time someone fed a fire instead of running from it, and it obeyed. Prey learning to command the thing every other prey animal fears. That reversal alone is one of the strangest turns in the story of life on Earth. Proving it happened and figuring out who did it has occupied archaeologists for over a century because ash disintegrates and charcoal blows away. A campfire from 1 million years ago rarely leaves anything you can point to and say, with confidence, a person made this. At Wonderwerk Cave in South Africa, the site with that deep deliberate burning, researcher Francesco Berna and his colleagues didn't rely on visible ash at all. They used a technique called Fourier transform infrared microspectroscopy, reading the microscopic chemical signature that burning plant matter leaves behind in sediment, far past any point wildfire could plausibly reach. Their dating placed the burning at roughly 1 million years ago. The toolmaker most closely associated with that region and era wasn't us. It was Homo erectus, but there was a problem. Having fire and knowing how to make fire may not have arrived together at all. At Gesher Beno Yaakov in northern Israel, researcher Nama Goren-Imber's team found burned flint and wood clustered in patterns that looked less like scattered wildfire debris and more like something organized around a hearth dated to roughly 790,000 years ago. Suggestive, not conclusive. And when archaeologists compared sites like these across Africa and Eurasia, they noticed something strange. Fire evidence appears at a location, then vanishes for tens of thousands of years, then reappears somewhere else entirely. That is not the pattern you'd expect. Expect from a species that had cracked ignition. Looks far more like a species that knew how to keep a flame alive once it had one, gathered from a lightning strike or a smoldering brush fire, but hadn't yet solved the much harder problem underneath it. Not finding fire. Making it. That reframes the whole question. The real leap probably wasn't discovering that fire existed or even that it was useful. It was solving the maintenance problem, tending a flame day after day, feeding it, shielding it from wind and rain, thinking hours or days ahead in a way that raw survival rarely demands. That's not just a physical challenge, it's a cognitive one. And if fire wasn't originally about warmth at all, what was it really for? This is where the story stops being about ash and flint and starts being about something Harvard primatologist Richard Wrangham has spent decades arguing reshaped the entire human lineage. Cooking. Wrangham's idea is disarmingly simple and genuinely startling once you sit with it. Raw food is expensive to process. Chimpanzees, our closest living relatives, spend nearly half their waking hours chewing raw plant matter just to extract enough calories to survive. Cooking breaks down tough fibers and proteins before a single bite is taken, effectively pre-digesting food outside the body. Wrangham's argument is that this freed an enormous energy surplus, energy no longer spent on massive jaws and hours of chewing that could instead be redirected toward the most expensive organ in the entire body. A brain that in modern humans burns roughly a fifth of our daily energy, despite being a fraction of our body weight. The idea is powerful. It's also still debated, because archaeology can't simply rewind evolution and show us the exact moment cooking became routine rather than occasional. But if Wrangham is even partly right, fire didn't just keep our ancestors warm at night. It may have quietly financed the very organ that would eventually ask where fire came from in the first place. Sit with that reversal for a second. We usually imagine bigger brains came first, and clever inventions, fire included, followed as their product. This hypothesis flips the order entirely. It suggests fire, or at least the caloric windfall it unlocked, may have been a precondition for the larger brain, not a result of it. Cause and effect swapped, but calories were only the beginning. Fire changed something else too. What happened after the sun went down? A fire has to be shared to be worth keeping. You can't cook alone in the dark and still expect to defend a flame from a rival group, from rain, from your own exhaustion, without others willing to take a turn watching it. Anthropologists studying fire's social role point to something almost obvious once it's said aloud. The hearth may be the first stage humans ever gathered around, the earliest fixed point in the day when a group sat still together. Faces lit from below, doing something almost no other primate activity allows for, extended, unhurried time together after dark, when every other animal on the plain was hiding. Some researchers propose that this nightly ritual gave early social behavior, some storytelling, and eventually more complex communication room to develop in a way daylight survival never permitted. That's not a claim that fire caused language. It's more careful than that, and more interesting. Fire may have created the conditions in which increasingly complex social behavior could take root at all. Archaeologists can study the ash. Evolutionary biologists can study the caloric math. Anthropologists can study what a shared hearth did to a group after dark. But long before any of that science existed, humans themselves remembered something else about fire, something none of that evidence fully captures. Across cultures separated by oceans and millennia, fire origin myths recur with startling consistency, stolen from the gods, gifted by a trickster, torn down from the sky. Prometheus, chained to a rock for eternity for handing flame to mortals, is only the most famous version of a story told, in variation, almost everywhere humans have lived. It isn't hard to see why. If you don't understand combustion chemistry, and you watch something this transformative pass from an untouchable force of nature into human hands, theft from a higher power is a remarkably reasonable explanation. The myths weren't foolish. They were reaching for the same scale of significance the archaeological evidence now quietly confirms. Fire was never just another tool, which brings this back to the cave, and to the honest, unresolved center of the whole story. Researchers can place hominins near controlled fire nearly 1 million years ago. What they still can't tell you, with certainty, is when those same creatures crossed from keeping a flame alive to striking one into existence on command, from opportunist to inventor. That gap in the record isn't a failure of the evidence. It's a genuinely open question, one actively being narrowed site by site, technique by technique right now. 1 million years ago, it was only a small flame in a dark cave, tended by something not yet fully human. The world we live in is, in countless ways, downstream of that ancient decision to keep a flame alive. We still don't know who struck the first spark. We only know that, long before us, something learned that fire didn't have to be feared. It could be kept, fed, carried, used. And somewhere in that cave, a kilometer from the light, without any way of knowing it, something began tending the first link in a chain that has not gone out since.